Please turn to the back side of our double angles formula, which is lesson 3 from unit 12, and we're going to look at number 5. So we want to verify identities, and we did this in unit 11. A lot of you did not care for it, but we're going to do that again. Please take out this piece of paper as we try to apply these. So the very first thing I'm going to do is I'm going to ask myself, okay, what is the cosine of 2x equivalent to? And when I look at this paper, I can see there's 3 different versions that I could apply. 3 different versions I could apply. Now, on the right-hand side, I'm going to take this and apply it to the left, and I'm going to apply it to the right. Okay, so I'm going to rewrite this as 2 over the secant squared x, subtract secant squared x over secant squared x. I have not chosen which version I want to use from the list. I just want to prove the left side is equal to the right side. Now I can rewrite this. I know secant squared is the reciprocal of cosine squared. So when the secant comes up to the top, I'm going to rewrite it as, as the cosine squared. The next thing I recognize is on the right-hand side, I have secant squared x divided by secant squared x, which is equivalent to 1. Okay, so before I do anything with the left-hand side, I want to see, does any one of these versions match this? And I can see that cosine of 2u, by the way, it's the same thing as the cosine of 2x, is equivalent to this form. So I'm going to write down on the left-hand side 2 cosine squared x minus 1. 2 cosine squared x minus 1. The left side equals the right side. We've verified problem. This time when I look at problem number 6, so this is 1 plus the cosine of 2x divided by cotangent squared x equals 2 sine squared x. What I'm going to attempt to do is not to have no fractions. So cotangent is on the bottom. This is like 1 divided by cotangent. So I'm going to multiply the left and the right side by cotangent squared x. So the cotangent on top and the cotangent on the bottom are going to simplify to 1. And I have 1 plus the cosine of 2x equals 2 sine squared x. And now I know that cotangent squared can be rewritten as, bless you, cosine squared x divided by sine squared x. What I have found last year when students were doing this is that too often students saw the cosine of 2x and immediately they wanted to choose one of these options. I'm going to wait to the end to see which option should I choose so the left side will naturally match up with the right side. Okay, on the right hand side, sine on top and sine on bottom are going to simplify to 1, and I'm left with 2 cosine squared x. Now on the left hand side, notice that my right hand side only has a cosine squared. So when I identify the 3 different options for the cosine of 2x, which are right here, I want to choose the option that only has cosine squared. So this one has cosine and sine. I don't want to use that option. This has cosine squared. That's good. This has sine squared. I want to choose the option that only has cosine squared. So I'm going to write and replace cosine of 2x with this quantity. So I have 1 plus, and this is where I'm going to substitute in, 2 cosine squared x minus 1. Now on the left hand side, these are additive inverses. 1 and negative 1 are going to end up canceling out because they equal 0. And I have 2 cosine squared x equals 2 cosine squared x. The left side equals the right side, and we are done with. This is number 7. Again, we are on lesson 3 and unit 12. Now I want to review with you a few things. If I said to you x squared, you do not have to write this down. X squared minus 4, hopefully you recognize that 1 breaks into 1 and 1, 4 breaks into 2 and 2. I can divide this number by 2 to get x and x, and as long as I have subtraction, I have 1 x's in front, 2's in back, so 1's positive and 1's negative. Now, could we do that same concept you were just watching? When we have 2 variables, yeah, breaks into x and x, breaks into y and y. I have subtraction, so it's going to be x plus y and x minus y. What do we do when that number changes to a 4? When that number changes to a 4, as long as this number, this exponent, can equally be separated into two groups, which it can, x squared and x squared, and y squared and y squared. Then we have x squared plus y squared and x squared minus y squared. But just as a little side note from freshman year, why would I not be done right now? This is true, but why am I not done? I can go further. Which one can I go further with? Is it the left or the right? It is the right. Why can I go further with the right but not the left? Has to have subtraction. This is x plus y and x minus y. And so why am I doing this? Because I'm going to come up here and I recognize that in this problem, which is problem 7, I can separate this into cosine squared and cosine squared. I can separate this into sine squared and sine squared. These two numbers have to equally be divided. So can they be separated and end up in an integer value? Yes, they can. Yes, they can. And we have to have subtraction. So I'm going to make my two parentheses. The cosine squareds will go in front. The sine squareds will go in back. And what's the reason for that? Because it comes from the front and it comes from the back. One of them is addition, one of them is subtraction. Like I said in the previous problem, I have the cosine of 2x. And when I look at my answer key, the cosine of 2x has 3 separate options. At this point, I don't want to have to choose. I don't want to have to choose right now until I know what is the left-hand side looking like. Okay, which one of these should be familiar to you based on what you learned in Unit 11? Is it the first parenthesis or the second? And why is that? Because we've learned the most common Pythagorean triplet, or Pythagorean identity, is sine squared plus cosine squared equals 1. So this portion right here is going to turn into a 1. And when I take 1 times cosine minus sine squared, nothing's changing there. Multiplying by 1 doesn't change anything. So now I'm looking and I'm going, okay, cosine of 2x. Oh, look it. The cosine of 2x is equal to cosine squared minus sine squared. So this is cosine of 2x is what this is equivalent to, equals the cosine of 2x. The left side now equals the right side. So if you are just simply watching this, I probably spent 5 to 8 minutes on trying 3 different attempts, entry points into problem number 8, and I was unsuccessful. And thanks to the help of Ulysses Sanchez, he was able to provide us a different insight into proving the left side equals the right side. So it's going to be much easier than I was attempting. Please no talking and making sure you're writing this down. So we know the tangent is exact. By the way, I saw a tangent of 2x. I took out my cheat sheet, and I can see the tangent of 2x is equivalent to this quantity. That's what I wrote down. So that's how I have the left-hand side. Now I'm going to rewrite tangent as sine of x over the cosine of x. And then I'm going to divide that, please no additional talking, by 1 subtract, and I know that tangent squared is sine squared x over cosine squared of x. In the denominator, I could use the McFarland method, I could use the butterfly method. Ultimately, I want to find a common denominator, right? And so either of those work. Myself, I know that 1 is the same thing as cosine squared over cosine squared. Please no talking. Cosine squared x divided by cosine squared x equals 1. And so now when I simplify this, I have 2 sine of x over cosine of x divided by cosine squared x minus sine squared x, all divided by a common denominator of cosine squared x. This right now is the left-hand side. Let's look at the right-hand side. I'm going to come back here. I'm going to rewrite cotangent as, what is cotangent equivalent to? Cosine of x divided by the sine of x. Then we're going to divide this by, I'm rewriting cotangent as cosine squared over sine squared minus 1. But what's a better way for me to write 1 when I know I want to combine these? Anyone? Sine squared or sine squared, because I know that this is equivalent to 1. Okay, so this is what I have. Now I'm going to rewrite this. I have 2 cosine of x over sine of x divided by cosine squared x minus sine squared x divided by sine squared. I'm going to give you a chance to get caught up. I've done the left side and the right side right now. Okay, so I'm going to work on the left-hand side here. So I have 2 sine of x over cosine of x. And then when we divide, normally I would write, and I'm going to be lazy here, normally I'd write divided by, and I'd write this quantity out. And then I would remind us when we divide fractions, we turn division into multiplying, and I flip the second fraction. So on top will be cosine squared, which is the same as cosine times cosine if I expand it. And the denominator would be cosine squared minus sine squared. Hopefully you can see what automatically cancels out right now would be the cosine and the cosine. And so I'm left with 2 sine of x cosine of x over cosine squared minus sine squared. Let's see what we can do with the right-hand side using the same philosophy. Bless you. I'm going to write down 2 cosine of x divided by sine of x. And then I'm going to turn division into multiplying, and I'm going to take this second fraction in the denominator and I'm going to flip it or take the reciprocal. Sine squared times sine squared is sine squared is sine x times sine x when I expand it. And then I have cosine of x minus the sine of x. Okay, what happens to one of the signs on top and one of the signs on the bottom? They're going to be reduced down. So this is my left-hand side, and my right-hand side is 2 cosine of x sine of x divided by cosine squared x minus, and this should have been a square here, minus sine squared x. Now the left-hand side equals the right-hand side. In the past, I have had students that have questioned and said, "Are you sure, Miss Bradley?" Because I'm talking still, should be quiet. Because here you have the sign written first, and then here the sign is second, and vice versa. When you're multiplying, the order you multiply in does not matter. Left side equals the right-hand side. Please move forward, and I want you to complete the last 2 problems, which would be